So in this lesson, we're going to learn about a special case of percent composition. This one involves something called hydrates, otherwise known as hydrated salts. And typically percent composition is where you find the mass of an element within a compound. But for hydrates, we typically want to know the mass of the water in a hydrate. Now, a hydrate is an ionic compound where water molecules have gotten trapped within the crystal lattice. And so when you heat it, the water evaporates but does not destroy or decompose the crystal structure. So after heating, the water is now gone, and all you're left with is the anhydrous, or the dried ionic compound. We typically represent the chemical formula. The ionic formula is followed by a dot. It's not a multiplication sign, it's just a dot showing that how many water molecules are attached. So this one is the mineral selenite, otherwise known as gypsum. It's calcium sulfate dihydrate. There are 2 molecules of water trapped for every 1 formula unit of calcium sulfate. So the general formula to use is the mass of the water molecules, all of them, so in this case both waters, and divided by the mass of the hydrate. Now the hydrate is the entire thing. So you might want to think of the equation like this. The percent water is the mass of all the water molecules divided by the mass of the salt, right? The calcium sulfate is the salt. But also you want to make sure that you're including the mass of the water molecules. So the hydrate is the salt itself plus whatever water molecules are attached. And then of course multiplied by 100 because you're putting it into percent form. So grab your periodic table, grab your calculator. Let's calculate the percent water in calcium sulfate dihydrate. So water, if we figure out the mass of 1 water, there are 2 hydrogens, right? And each hydrogen has a mass of 1.01. So that's going to be equal to 2.02. There's 1 oxygen, and it weighs 16.0. So we need to add 2.02 to 16.0. Following sig fig rules, the mass of water, a single water, is 18.0 grams per mole. So this is a number that's just going to become quite common in your usage. And so if we have 2 water molecules, it's just going to be twice this. So if we say the percent water is 36.0 grams, right, because that's the mass of 2 water molecules, we have to divide that by the mass of calcium sulfate plus the 36.0 grams. So let's just take a moment to calculate the calcium sulfate, right? So calcium is 40.1. Sulfur to the nearest tenth is 32.1. And 4 oxygens, each at 16, is 64.0. So if we add those 3 numbers up, we've got 40.1 plus 32.1 plus 64. We're going to get 136.2, right? So that's the mass of just the calcium sulfate. And let's put that in here, 136.2, okay? So let's simplify this. 136.2 plus 36. Our denominator is going to be 172.2 grams. Our numerator is still 36.0 grams. Okay. And obviously I have not really given myself a whole lot of room, but when I simplify this, I'm going to do this underneath now. 36 divided by 172.2. And then, of course, I want to multiply that by 100 to put it into percent form. So times 100, and we're going to get 20.9% water. Okay, so in calcium sulfate dihydrate, 20.9% of that mass is coming from the water. So this is essentially how you do this. You know, it's the same exact strategy. This next example, we've got a hydrate called nickel 2 sulfate heptahydrate, hepta meaning 7. Here we have sodium carbonate decahydrate because there's 10 hydrogens. So it effectively works the same way. Let's just set it up quickly. We'll do one more problem like this together. Right, so we know that 7 waters, right, each water is 18, but 7 of them are going to be 126.0. And then down here, 126.0 grams. And so now we just have to figure out the mass of nickel sulfate. And so nickel has a mass of, what is that? 58.7. So 58.7 plus sulfur, which we already know from the previous problem is 32.1, plus 4 oxygens, that's 64. So adding that up, so that's going to be 154.8. Simplifying this, let's see, 154.8 plus 126. Our denominator is going to be 280.8. Our numerator is still 126.0 grams. Multiply that by 100, and our percent water is going to be 44.9%. Okay, so that is how you do a percent water and hydrate if you are only given the formula. Okay, but in reality, or at the lab bench, you would be starting with the hydrate, like you might have a sample of nickel sulfate heptahydrate, and you put it in a special container, ceramic container called a crucible. You heat it. After you heat it, the water is all dissipated and you are only left with the nickel sulfate. So we can also figure out percent water and hydrate by doing lab work, by doing an experiment. Okay, and so that's this next part of this lesson. Right, the hydrate is the compound that contains trapped water molecules within its crystal lattice structure. When you heat it, the water evaporates, leaving behind a dehydrated substance known as the anhydrous salt, or sometimes the anhydrate. Right, anhydrate. An basically negates the root word, so hydrate means water, so an means without water. The mass of the substance before it's heated includes the trapped water. The mass of the substance after it's heated does not include the trapped water. So the difference between those two masses is going to give you the mass of the water itself. As I said earlier, this experiment's typically performed in a ceramic crucible. It's a ceramic, because ceramic can withstand high temperatures without cracking. We need to make sure we account for the mass of the crucible and its cover if a cover is used. We want to make sure that we're not including the mass of the crucible because that is not the hydrate. So you are, the direction here is during an experiment to determine the percent by mass of water in an unidentified hydrated crystal, a student whose name is Molly Kuehl obtained the following data. So the empty crucible with its cover, the container holding the salt with its cover, this is 10.439. So this is without the chemical. Now we have the mass of the crucible and the cover and the hydrated salt. So this is before heating. We have 11.844 grams. So the difference between these two numbers is going to give you the mass of the hydrated salt itself. After you heat it and all the water has disappeared, we take another mass. We have the mass of the crucible, the cover, and the anhydrous salt. And notice that this mass is a little bit lighter than the hydrated salt. And that should make sense. The anhydrated salt should be lighter in weight because the water has disappeared. Okay, but notice that both of these masses include 10.439 grams of crucible. That's the container. So that mass would have to be subtracted from both of these to find the mass of the hydrated salt as well as the anhydrated salt. And that's what we'll do down here. So the question is, what is the approximate percent by mass of the water in the hydrated salt? First, find the mass of the water. Okay, so the mass of the water, the hint is to find the two masses where the only difference is the presence of water. So that would be, if we're calling this A, B, and C, B is the mass that includes the water, C is the mass that does not include the water. So 11.844 grams minus 11.213 grams. Do that in the calculator. We could probably do this without a calculator, but it feels so much more secure to do this with a calculator. So we're going to get 0.631 grams of water. Okay, so that's going to be our numerator for our percent water in the hydrate. The denominator has to be the mass of the hydrate itself. So we need the mass of the hydrated salts right here, but we're going to have to subtract out the empty container. So 11.844 grams minus 10.439 grams. We're going to get 1.405. That's the hydrate, or the hydrated salt. Now we can do the percent composition problem, right? So the percent water is the mass of the water, 0.631 grams, divided by the hydrate, which is 1.405 grams times 100. 0.631 divided by 1.405 times 100. 44.9% water. Okay. So now the question is the substance nickel 2 sulfate heptahydrate or sodium carbonate decahydrate? So if we go back to the previous page, we did not do the decahydrate problem. We did do the nickel sulfate problem where we saw the expected percent water to be 44.9% based on the chemical formula. But here, when this student did this in the actual lab bench, because we got 44.9% water, chances are that that's the nickel sulfate heptahydrate. If we wanted to be absolutely sure, we'd have to go back and do this problem. So let's just do that to validate. Right, we've got 10 waters, so that's 180. 18 times 10 is 180. So let's just validate that. 2 sodiums, each at 23.0. The carbon is 12.0. 3 oxygens, each at 16, is 48. So 48 plus 12 plus 46 is 106. So let's simplify that. This is 180. 6 plus 180. So adding that denominator, we get 286. No, divide. 180 divided by 286 times 100. So we're going to get 62.9% water. So what we see here is that based on the chemical formula alone, we would predict that this substance would have 44.9% water. And this student, when they went to the lab bench, they didn't know what it was, but when they determined the percent water to be 44.9, if they're choosing between these two, it must be the nickel sulfate heptahydrate based on the chemical formula work. So in this lesson, we have learned how to do percent water in hydrated salts. We've learned how to do this based on just a chemical formula, which gives us the what we would call the accepted percent water, or what the predicted percent water would be. And we also learned how to find the percent water in a hydrate based on doing the work in an experiment at the lab bench by heating up the substance, letting the water be evaporated off to find the difference between the hydrated salt mass and the anhydrated salt mass. And from there we can find the percent water from an experiment. All right, that's it for this lesson. We'll see you back in the classroom.